Welcome and study with Tanzania Institute of Education.
Hello, welcome to the most lovely subject of mathematics. In our today's session, we shall discuss the topic known as functions. My name is Pascal Titus Majebele, the teacher of mathematics. I will guide you in our discussion. In order to be together, make sure that you sit properly wherever you are. Don't move. You must have a ruler, a rubber, a pencil, and a notebook. To start with, function has got four things. Things which, by the end of this topic, everyone should be able to discuss them. That's the first thing is the concept of function. That means, by the end of this topic, everyone should be able to define, to explain what is a function. Concept of functions. The second thing which every one of us should be able, by the end of the lesson, to explain it, are the methods of representing functions. The what? The methods, representation of function. Representation of functions. To each method which is represented, you should also be able to determine the domain and range. The third thing here is domain and range. The last but not least is the inverse of the function. The inverse of the functions. Those are the four things which, by the end of this topic, everyone should master them. If you are able to master this means, this parts, it means you are okay with the functions. Let us start with the first thing. That is the concept of function. To understand the concept of function, look at the following. Concept of functions. You can use other words. Instead of saying concept, it can be what's the meaning of functions. To understand this, consider the following. Let us have two sets. Set A and B, such that A is a set of children. That is, let A be set of children. And the second set, that is set B, be set of fathers. Set B, set of fathers. Upon illustrating these two sets, that is, I have the first set there, call it set A, with the elements A, B, and C. These are children which are in this set. And another set, set B, with the elements, let's call them X and Y. Let's make two different illustrations. This is the first illustration, and let me make another second illustration here of the same set. Here, this is A and this is B. Elements of A, we have already said it's A, B, and C. And elements of B are what? X and Y. Call this is the first illustration, and this one here is the second illustration. Now, we need to relate the element of set A to those elements of set B. How can we relate them? We have to use arrows. Let's say this child here, A, is related to this father X as shown by the arrow. Here, we have this one here. And again, the same element, that is the same child, is related to y, as again shown by the arrow here. Let this child here, b, is also related to y as it is shown there. C is related to y as it is shown by the arrows. To the second illustration, let us relate A, B, and C with those elements of x as shown by the arrows here. Let me take this A related to x. This B here is also related to x. And this C here is related to y. Mind you, set A is the set of children, and that of B is the set of fathers. Now, can you tell me which of the two illustrations is correctly labeled? Look at this. Mind you, this is a child. It is related to x. A is a child, x is the father, and y is the father. In real concept, is it true that a child can have two different fathers? The answer is no. So it means if A is the set of children and the B is the set of fathers, the first illustration is not correct. Let's go to the second one. We have seen that a child A and a child B are connected to the father X. Is it true that a father can have two different children? Yes. The answer is yes. So it means the second illustration is correct. Now I want you to give you the concept of function. All these are relations. I believe you know the relations because that's the first topic in Form 3. Now all these two illustrations, they are relations. But the second relation has got something more, that it is conditioned. Now this one which has got illustration, we call it a function. Now the second illustration gives us what we call a function. But this one here is not a function. Not a function. Now with those explanations, I think you can give me the definition of the function. What is function? Everyone can use his or her own words to define the function from all this we have explained. But not only, here we have seen the representation of the function by using this pictorial. Let us, from this illustration or from this pictorial representation, let us write the set of ordered pair by using these two diagrams. If you have already written there, I would like to lab part of that one so that we can see when a function is represented differently. How can you determine this is a function or this is not a function? Now let's have a look. I've retained this one because what I'm going to prepare here depends on these two diagrams here, especially this one which is a function. That is, from the first illustration, upon representing the pictorial diagrams below, diagrams below, I'm sure you remember from relations. These are known as pictorial representation of relations. Now, upon representing the pictorial diagrams below as a set of ordered pair, pairs, we'll have the following. From the first illustration, I, in the set of ordered pair, A is related to X, which can be represented A, X. That's the first ordered pair from this one. The second ordered pair from this one, it is A, Y. That is A, Y. Is there any other ordered pair from the first illustration? Yes, there is. A, X, A, Y. Another one is B, comma y. Thank you. This is B, comma y. Another ordered pair which can be established from this pictorial here, C, comma y. C, comma y. Is there any other? No. In the second pictorials, the following ordered pair can be obtained. What are they? It is the first one, A, comma X. Good. A, comma X. Can you give me the second ordered pair from the second illustration? The answer is yes. It is. Look at the arrows. The arrows will give you the ordered pairs because the ordered pair is obtained from the elements which are connected by the arrow. That's where at the beginning I took A and X to give me the first ordered pair. The second ordered pair will be A, comma X. Just look at the arrows. Will give you an ordered pair. That is, we have B, comma X. The last one is the C, comma Y. C, comma Y. Now I can lab this one to get a place where I can proceed with our discussions. Now, as we said, the first is obtained from the first illustration. And we said the first illustration was not a function. Why was it not a function? It is because a child cannot have more than one father, according to the arrows. So we said the first illustration was not a function. So how can you see it here? You can see it by using these ordered pairs. Look at the first entry. In the first ordered pair, it is A. Look at the first entry. In the second ordered pair, is also A. That means it's solid that a child cannot have two different fathers. So this is not. If you are given a function in a form of ordered pairs like there, just look on the first entry. If there is an element, the same element in two different ordered pairs, then that is not a function. So in our case here, Roman 1 is not a function. It's not a function. If you come to the second here, what is the first entry in the first ordered pair? Is A. Is there any other ordered pair which has got the same which has got A? No. In the second ordered pair, the first entry is B. Out of our three ordered pair, is there any other which has got B? No. The last one is C. Is there any other ordered pair which has got C as the first entry? No. That means it's the condition for the function. So the second one here, Roman 2, is a function. Is a function. So by using these two explanations, you can now give me a very good definition of a function. I wish I could see what are you defining there. What is your relation? What are you defining there? I know you are writing a very good definition of the function. You can compare with mine, which I can define by using this. And then it doesn't matter that we should not necessarily use the same words, but the concept should remain the same. You can use whatever the language, the words you're using. I will use mine, she will use hers, he will use his. But the concept will remain there. What is the concept? It is this, that if I define by using the ordered pairs, I would simply say a function is a relation in which no two distinct or different ordered pair of the same set can have the same first entry. That is what I can define here. That is a function. Mind you, not necessarily that you have to use my words. You can define by using your own words. I'm defining in terms of the ordered pairs, that a function is a relation. Mind you, all these are relations. Is a relation in which no two distinct ordered pairs should have the same first entry. No two distinct ordered pairs should have the same first what? First entry. That is a function. That's the function. Hope you have also defined yours. Don't even leave it, as long as the concept is the same. It's the same. Now, let us have a look on some few questions here, which will see whether we can determine whether a given relation is a function or not a function. Allow me to lab here, if you have already written. Good. I'm rubbing here. Let us see some few examples here. Oh, haven't you finished? Let me leave this space for those who haven't finished. While I'm writing the question there, you will be finishing the remaining lines. All right? Okay. Let me see if I can find a question here. Looking if I can find one here. Determine. Okay. Examples here. No, we should not call it example. It should be your activity. I'm sure that I'm in the studio, but I'm looking at what you are doing. It is your activity. You have to do it in just a minute. Call it activity. State whether the following, state, that is number one, state whether the following relation is a function or not a function. Or not a function. You are given a relation. We know that's the notation for the relation. Everyone knows that. Let's say you have the ordered pair 2, 3, 4, 1, 3, -6, 5, 1. Let me give you one more, not only one. State whether the following relations are functions or not functions. We have this was the first one here. You have the second here, are it's -2, 1, 6, 5, a half, 0, and 2, -2, 5. Look at the following two relations. Can you tell me which one is a function and which one is not a function? Remember of what we have discussed there. How will you know that a given ordered pair is a function or not a function? Look at the first entry to each ordered pair. Okay? You have done it, I think. All right, let me go to your answer. Let me see what you have written there. What about the first one? Solution here. Is the first ordered pair a function or not a function? We have 2, 4, 3, 5. No repetition of the first order of the first entry. That is a function. This here, Roman 1, is a function. I think even Roman 2 is a function. Is it? Yes, I think even Roman 2 is a function. Let us have a look on it. The first entry. Only the first entry will determine whether this is a function or not a function. First entry, not second entry. I have the first ordered pair, -2. The second ordered pair, 6. Did not repeat, so it's okay. It's okay. The third one, it's a half. The last one, oh no, there is -2 here. That already makes that not to be a function, because there is a first entry which has appeared in 2 different ordered pairs. So the second one is not. It's not a function. It's not a function. That's the first activity. I'm going to give the second activity, and then we will proceed, but remind me to cross check whether you have done it correctly. I'm not going to do it here, but we have to proceed. Can I lab here? Thank you. I hope you have done this one here. That was question number 1. Question number 2. This is activity 2. From the pictograms, from the pictorials, it's pictorials, from the pictorial diagrams below. From the pictorial diagrams below, which of the two is a function and which one is not a function? Which of the two is a function? You have the first illustration here. You can even use dot to show these are the elements. These are the elements. Also, you have another 2 elements here. They can even be 3. There is a second illustration here. Second illustration here. It has got 3 dots. And there is another one here with only 1 element. Now let us relate the elements as usual. How do we relate the elements of the pictorial? It is by using the arrows. If I choose this one to be here, right? This one here, this one here, and this one here. Mind you, the arrows should have the initial and end point. You should put the direction of the arrow. The first illustration is here. The second illustration is here. You have this one here. You have this one here. You have this one here. I would like to add the second dot here. And also you have this one here. Now I'm leaving you this as an assignment. By the end, you should be able how to tell me which of the two is a function and which one is not a function. That is how the relation, the function can be defined or represented by using pictograms, pictorials, and also by using the second one, which is the ordered pairs. But I told you that representation of a relation, of the function, it is similar as the representation of the relation. In relation, we define the 4 different ways of representing relation. Also for the function, we have 4 different ways of representing. We have already seen the pictorial representation of the function as it is in activity number 2. And we have also seen the pictorial representation of a function by using the first one, which was by using the ordered pairs. There is another ways of representing relations by using equation and by using graph. But today, we'll only end up with this. When we meet in the next session, we will discuss the rest of the method in which the relation can be represented. To each of this. So this is your activity. Have you taken it? Have you taken it? Thank you. I'm labbing this one here to wind up our today's lesson. Now, dear lovely students, they're at home. Have you now understood what is a function? Can you now define what is a function just by using what we have learned here? Of course, the answer is yes. The answer is yes. So when we meet next time, there are questions here which I have to write for you. We shall proceed with other parts of representative of the relations. But because of time, we normally use, there are books which we normally use. This is one of the textbooks in which the topic function is found. There are numbers of questions of functions. At your home, ask your parents to buy, and I know that you have those books. Just go and look to the questions which are related. They are found in exercise 2.1. There are about 5 different questions. Attempt them at your home and ask your brother, your father, your parents when they get back home to do those questions. I will only write the questions because I have given you the reference. That take book 3, that is the assignments. I'm giving you now the homework assignment. The homework assignment. I have big eyes. You must do them at your home because I'm capable of seeing what you are doing at home. Before we start the next session, I will ask you whether you have done it, and I will have to mark them. Go to exercise 2, part 1. There are about, let me see them, hurry. There are about 10 questions. You don't have attempt. Attempt as many as you can. 2, 1. Yes, they are here. There are about 5 questions. There are about, not 5, 9 questions. May you please, you have enough time. Attempt all the 9 questions for your benefits. Right? Question number 1 up to 9. Thank you for today. It is my hope that when we meet next time, you will have already attempted these questions and you will be in a position of proceeding with the next part. Thank you for being with me. I'm your teacher of mathematics, Pascal Titus Majebele. Bye-bye.